Hi students, now let's learn about the carbon and its compounds. Organic chemistry, we know it is the study of the organic compounds, right? Organic chemistry, it is the study of the organic compounds. And what are organic compounds? Organic compounds are actually the compounds of carbon, right, which are mainly derived from the organic sources, from the living creatures. Compounds like carbohydrates, proteins, hydrocarbons, lipids, these are all the organic compounds. So the carbon with atomic number 6, and this is the position of the carbon in the periodic table. Its atomic number is 6 and its mass number is 12. Carbon with atomic number 6, electronic configuration will be then 2 and 4. So first shell, there are 2 electrons. So the first shell here in the carbon is filled. This is the nucleus of the carbon, and this is the first shell of the carbon. It contains 2 electrons here. So these are the 2 electrons. In the second shell, it contains 4 electrons. There are 4 electrons, 1, 2, 3 and the 4. So the valence shell here is not complete. We know that to complete octet, the carbon needs 4 more electrons. So to complete its octet, right, we can say the carbon can gain 4 electrons, okay, or it can lose 4 electrons. If it gains the 4 electrons, then its charge will be C4 negative, and if it loses the 4 electrons, it will be C4 plus. Carbon cannot gain the 4 electrons because the carbon with 6 protons, right? Inside the nucleus there are 6 protons. It cannot hold the 4 extra electrons, 4 negative electrons. So a nucleus with 6 electrons only cannot have 6 plus 4, so total will be 10 electrons, right? Here will be total number of electrons will be 10. So that means it has 4 extra electrons. Again, that is not possible, right? Now carbon with 4 plus, if it loses 4 electrons, that again is not possible, because it requires a very high amount of energy to remove the electrons, to remove the 4 electrons from the second shell of the carbon. Therefore, carbon neither gains the electrons nor loses electrons to complete its octet. So that means there is no loss and the gain of electrons in the carbon compounds. Rather, carbon completes its octet by sharing of electrons, okay, by sharing of electrons, okay, by sharing of electrons. The bond which is formed by the sharing of electrons is called as a covalent bond. A bond which is formed by the loss and the gain of electrons over here, that is an ionic bond. So the carbon forms covalent bonds in the different compounds. Since there are 4 electrons in the valence shell of the carbon, so therefore the valency of the carbon will be 4. Let's discuss first about a little bit more about the covalent bonds. A covalent bond, as I said, is formed by a covalent bond is actually formed by the sharing of electrons. Let's take a simple case of hydrogen molecule H2. Hydrogen atom with the atomic number 1, electronic configuration is 1. K shell, first shell, it contains 1. Okay, so if you have a hydrogen atom, it has a 1 electron in the valence shell. Another hydrogen atom with the same electronic configuration, 1 electron here. So these two hydrogen atoms, they share the electrons in between, and this electron pair becomes a common property for both the hydrogen atoms. The kind of a force which develops between the two hydrogen atoms by sharing of electrons is called as a covalent bond. So hydrogen molecule has a covalent bond. Let's take another example of the chlorine molecule, Cl2. Chlorine with atomic number 17, electronic configuration is 2 in the first shell, 8 in the second shell, and 7 in the valence shell. So valence shell contains 7 electrons, right? So chlorine has 7 electrons in its valence shell. These are the 2, 3, 4, 5, 6 and 7 electrons. Another chlorine atom with the same situation, so has same 7 electrons in its valence shell. Now these two chlorine atoms, to complete the octet, it needs 1 electron. Okay, chlorine requires 1 electron, so it can share 1 electron with another chlorine, and they form a chlorine-chlorine single bond. Okay, because the electron pair is being shared between the two carbon atoms, between the two chlorine atoms. So these are the non-bonding electrons of the chlorine. So in Cl2 molecule, we got one single bond, which is formed by the sharing of electrons, and each chlorine atom has 3 non-bonding electron pairs. Okay, let's take another example of HCl molecule, hydrochloric acid. In HCl, hydrogen, it has 1 electron in the valence shell. Chlorine got 7 electrons in the valence shell, 4, 5, 6, 7. So the valency of the chlorine is 1, valency of hydrogen is 1, so they share the 1 electron pair in between, and they form a single bond. A covalent bond is formed by the sharing of electrons between the hydrogen and chlorine. Okay, so let's take another example of the O2 molecule. Again, in O2 we find a covalent bond. Oxygen with atomic number 8, electronic configuration is 2 and 6. So it has 6 electrons in the valence shell. To complete this octet, it needs 2 more. So oxygen atom with the 6 electrons in the valence shell, like this. Another oxygen atom, same situation there also, with 6 electrons in the valence shell only. This oxygen atom requires 2 electrons, this oxygen atom requires 2 electrons, so they share the 2 electrons in between, right? So that means there are 2 electron pairs. So oxygen atom, another oxygen atom, they can share the electron pairs in between. This is the 1 electron pair, and this is the another electron pair, being shared by the 2 oxygen atoms. By sharing of the 2 electron pairs, right, this oxygen, it completes the octet, this oxygen also completes the octet, because this electron pair and this electron pair, it is being shared. One oxygen atom provides 2 electrons, another oxygen atom provides 2 electrons, so you get a double bond between the 2 oxygen atoms. So we have a double bond, a multiple bond is present. One bond, a single bond is formed by 1 electron pair. Since there are 2 electron pairs, so you get a double bond. Okay, fine. So let's take another example of nitrogen, N2 molecule. Nitrogen with atomic number 7, electronic configuration is 2 and 5. So it has 5 electrons in the valence shell. It needs 3 more electrons. So therefore the valency of the nitrogen will be 3. So valency of the 1, 2, 3, 4 and 5. So nitrogen atom in the valence shell, it has got 5 electrons. Another nitrogen atom, it also has got 5 electrons in the valence shell. To complete its octet, both nitrogen atoms, they require 3 more electrons. So therefore when they form a bond, they share the 3 electron pairs. Okay, they share the 3 electron pairs. This nitrogen atom, it provides 3 electrons. Another nitrogen atom, it also provides 3 more electrons. So when they share the electron pairs, this is the one bond, this is another bond, and this is another bond. So that means in nitrogen molecule you get a triple bond. Each nitrogen atom has 1 non-bonding electrons. Similarly, now let's look at the carbon molecule. Look at the carbon. Now let's take an example of the carbon. Carbon atom with atomic number 6, electronic configuration will be 2 and 4. So the carbon has got 4 electrons in the valence shell. So it can share the 4 electrons to complete its octet. It will not lose electrons, it will not gain electrons, so it will do the sharing, the covalent bond will be formed. The simplest molecule, simplest organic compound is the methane, with 1 carbon atom forming the 4 single bonds with the 4 hydrogen atoms, but the sharing of electrons. You know, the carbon atom actually, the carbon has got 4 electrons in the valence shell. Hydrogen atom, it also has a 1 electron. So this electron pair is being shared by the carbon and the hydrogen. Another hydrogen atom, almost the same situation, sharing of electrons. This one, again the sharing of electrons. Here, the sharing of electrons. So 4 bonds are formed. So you get the 4 single bonds in the methane. Now let's have a look at the 3-dimensional view of the methane molecule. Methane CH4, its structure is tetrahedral. So it has, in the center there is a carbon, 1 carbon, and there are 4 hydrogen atoms around it. And the angle is not the 90 degree here, right? The angle in methane is 109.5 degrees. So that's the tetrahedral angle. Now let's have a look at it. Now let's have a look at the 3-dimensional view of a methane molecule. In the center there is a carbon, around it there are 4 hydrogen atoms, right? These are the 4 hydrogen atoms, and this one is the carbon, the central methane, and this is now the 3D view. Okay, here I am going to rotate it, correct, the central carbon, and these are the 4 hydrogen atoms around it in a tetrahedral fashion. Hope you got the concept. Thanks for watching the video. Bye for now.